Okay, so we're going to go ahead and get started now. I think most of everybody has joined. Thank you all for taking the time to meet with us to discuss the Fish Passage project. So right now, I'd like to do some introductions of who's online, because not everybody can see everybody's name really quick. So just briefly, I'm Tanya Tabuki Herrera. I'm the project manager here at NID. John, you want to go next?
Yeah, I'm John Berge. I'm a project manager with McMillan Jacobs, and I'll be kind of managing that side of it for us.
Dave?
Hi, this is Dave Thomas with eCorp Consulting, and we are overseeing the permitting process for the project.
Kevin?
Yeah, Kevin Jensen, civil engineer with McMillan Jacobs Associates.
Doug?
Yeah, this is Doug Roderick, engineering manager, Nevada Irrigation District.
Chip? You might have to unmute at this point when I start calling on you. Okay, I'm going to go to Jim next. Jim Hoffler.
Yes, ma'am. Jim Hoffler with Friends of Auburn Ravine. Thank you.
Thank you. Steve.
Hi, Steve Hubbard, also with Friends of Auburn Ravine.
Ashley.
Ashley and Drury with Family Water Alliance.
Beth.
Hi, this is Beth Lawson with the California Department of Fish and Wildlife, engineer for Region 2, CDFW.
Chris McKibben.
Hi, this is Chris McKibben. I'm a fish biologist with the California Department of Fish and Wildlife.
Chris Stabenfeld. You might have to. Hi.
With eCorp Consulting. I'm the project director for the eCorp team.
Heth Wakely. Sorry for butchering last names here.
It's okay. It's Heath Wakely, Friends of Auburn Ravine.
Jean.
Hi, Jean Costello, NOAA Fisheries.
Jeff Wilson.
Yeah, Jeff Wilson. I represent the property owners and lease the land that we're talking about.
Jim Long.
Hi there, I'm with the Department of Water Resources for the Stewardship Program.
Matt Myers. Matt, you may have to unmute yourself. Okay, moving on. I have a M. Cavani. Moving on, I have Neil McIntosh.
Hi, Neil McIntosh, biologist, NOAA Fisheries.
And then Patrick. You may have to unmute yourself, Patrick.
Whoops. Hello, can you hear me?
Yep.
Hi, this is Patrick Moser with California Department of Fish and Wildlife. Work on implementation of the HCP, NCCP, and right streambed agreements for Placer County.
And Randy. Randy, you may have to unmute yourself. Okay, moving on, Scott Johnson.
Hi, I'm with Save Auburn Ravine, Salmon, and Steelhead.
And I think maybe our call in here is Chip. Is that you? You may have to unmute yourself.
Yeah, this is Chip. Sorry, Tanya. My high-tech computer does not have a built-in microphone, so I had to call in instead.
Yeah. No worries. Okay, so for unmuting, Matt, you have to, are you called in too, or you just?
No, so I'm here now, but at first, and I have a feeling other people are seeing this too, that you have to dig in pretty deep to find your microphone settings, and even still, it's not clear how to unmute it. But then you did something to enable me to unmute myself, and now I can do it the normal way. So anyways, okay. I'm Matt Myers. I'm with DWR. I'm an engineering geologist, and I'm with the Riverine Stewardship Program.
Great, thank you. Okay, so if everybody can just make sure they're all back muted so there's no feedback, we'll move on. So the intent of the meeting, hopefully you've all have seen the documents that we sent out. On the website, we have a report called the Design Concept Report. We also included a design concept plan sheet. Hopefully you had the opportunity to review that. We're going to go through that, or I should say, John's going to go through that information and be able to answer any questions that you may have. The goal here is to get your comments and feedback about the direction that we're going and get everybody comfortable with this concept so that we can move to the 50% design phase. So with that, please keep in mind anything that you would like to see us put in our 50% drawings, any conditions of permitting that you would also like to have reflected in those drawings, anything that would make the permitting process smoother would be absolutely helpful. And then we'll also have Dave go through what we are seeing as the permitting that we have to do and any constraints there. So at this time, I'll go ahead and turn it over to John.
All righty, thanks, Tanya. And it's good to meet you all, I guess, sort of meet you all in this way. I'm going to work on sharing a screen here and see if we can get that to work right. When I tried this before, it took it just a little while to load up. So let me know, are we coming through there? You guys see my screen yet?
I see it.
All right, super. Yes, like Tanya mentioned, just want to take a little while here and kind of walk through some of our concept design project that we put through, or that report we put together. Really hit on some of these bullets you see here, and then I just want to leave a fair amount of time for questions. And I'm confident that you have a lot of questions now, and you'll have a lot of questions later. And I'm also confident that Kevin and I will have some answers, but a lot of the answers that we're going to need to have are things that we will kind of develop as we move from a concept design into that 50% design. And so we'll do the best we can, and we'll see what we got. So first of all, I thought it'd be good to just look at a couple of the design criteria, just so we're working through. But first, just a quick overview. That's what I had in there. So just so we're all kind of on the same page, we've got Auburn Ravine here that's flowing down this direction. This is the existing facility right here. The existing Hemphill Dam is right there. The existing canal kind of flows out this direction. And so we'll be looking at removing the existing concrete diversion dam. We'll be looking at replacing it with what's called a roughened channel, or a rough rock ramp, or a nature-like fishway. Goes by a lot of different names. So that would be coming right in here. And then we'd have the fish screen facility we're looking at would be located out here in the canal, not in the ravine right there. So just to quick orient yourself with all of that. Just a few of the criteria. So some of the biological criteria we're looking at is the species of concern, which again, I'm sure many of you guys know already, is that Central Valley Fall Run Chinook salmon and this California Central Valley steelhead are kind of the two main ones. And then the Pacific lamprey is also a California species of special concern. And so those are really the three main species we're looking at as we try to move forward on coming up with solutions that work. Here's some of the migration timing that we put together for all three of those species, which kind of drops down to this kind of fish passage window down here at the bottom from early October to late June. Kind of quick on Auburn Ravine flow criteria. So really the flow criteria that we're using are based on the analysis of the stream gauge. It's located down by Lincoln Boulevard. Is that right? I'm trying to catch up. Previously known as downstream of Highway 65 gauging station. So when we look at the data stream there from 1995 to 2021, we come up with these exceedance flows. And these kind of define a low flow at the 95% exceedance of 13 CFS and a high flow at 5% exceedance of 172.5 CFS. But if you guys have been messing with Auburn flows for a while at all, you know that stream gauge only gauges up to about 200 CFS. So we know there's a lot of high flows that we're missing in that. And certainly the low flow is a concern for fish passage, but likewise the high flows are concerns for velocity and just stability of the system. And you can see that some in these 50 and 100-year flow events come out of the FEMA FIS flood insurance study, and they have a 100-year flow event of 15,000 CFS, which is significantly higher than this 5% exceedance. And so at this point, kind of all I want to communicate is as we move kind of from this point into the 50%, we'll also be doing a hydraulic modeling and kind of putting together a hydraulic report of these things, of that model that we create. And so we'll be looking at flows from this low flow of 10 or 13 CFS right on up through 200 CFS to 500 to 1,000 to 3,000 to 5,000, all the way up to 15,000. So we'll be looking at flows kind of all through that range and really seeing both trying to verify that we can provide passage at a low flow, but also that we create a system that's stable at the higher flows. And so that's something that will be coming along. We just don't have that at this point. As far as the canal flows, the timing on that is generally from April 1st to October 31st. And again, these looking at flows from 2011 to 2021, kind of minimum flow is around 3 CFS and maximum flow is around 9 CFS. So those really create kind of the design criteria as we look at screening. And certainly the headgate design and the screen are going to need to deal with debris management, with sediment, with the fish management. But those are all things that need to be handled there. Some of the fishway criteria. So for this roughened channel, some of the criteria that we're working from is really based off of a lot of the NIMS criteria from their 2011 criteria book. And the length, they try to keep the length of these roughened channels below 150 feet. So keep them shorter than that. We try to keep the slope lower than 6%. We try to maintain at least a foot of flow depth in that low channel and really in all flow conditions. This transport velocity is something that we try to keep that transport velocity down lower to where the fish can swim through that well. And so it's really will be affected by material placement. And as we'll see, as we kind of look at the design a little bit more, there will be a lot of different types of material placed in different places in this roughened channel that will provide areas of refuge and also provide areas of quicker moving water. So there will be a lot of variety in that. One of the challenges that we have is this minimizing subsurface flow, because if you can imagine you put a bunch of big rocks out in a river, all the water is going to go down to the bottom, and that's not going to be helpful for fish. And so there's really a lot of thought that goes into what that fill material looks like, so that it's rough enough to create the roughness we need, but also that it's got enough smaller material in it to keep the water on the surface. And one of the references we use comes out of Washington Department of Fish and Wildlife, and WashDOT has put together some pretty good guidelines on stream bed development of what those, how to the gradation of that material for the cobbles and the rocks and the boulders that go in there. Material placement will be very important, just to make sure that rocks get placed correctly and in the right spot. These all kind of end up getting hand placed out there in the ravine. We'll need to minimize head cutting. So both on the upstream and the downstream end of this roughened channel, we'll put controls that kind of define those 2 points so that they're not moving. And then bed load transport. We know that it's a natural stream, that there's sediments moving downstream. And so how do those filter into, through, on, over this roughened channel? Will all be things that we'll be looking at as we build that hydraulic model and study that a little bit more. Just some of the fish screen criteria. We'll end up looking through screen material. We'll be looking at diversion, shut off. You guys are seeing you guys see that right there, don't you? How do I move that? Oh, I just caught up with that. So the screen material will be something we'll be looking at, making sure there's the ability to shut off the diversion if something goes wrong in the system, the ability to remove sediment, because whatever we do at the trash rack, there'll still be sediment that will come into the canal. These screen approach velocities are important to make sure that fish don't get impinged on the screen or stuck there. That goes right along with the sweeping velocity of trying to make sure that flow is moving over the surface of the screen quickly enough to keep things moving on downstream. And some of these criteria are for other possible screens that we could have looked at, like drums, inclined screen faces, some of those things that really won't apply to us with looking at this option right here. But then these openings will be important. We've got these things that are criteria to make sure the screen material is made, has the right openings to it. So there's those things. So here's this, what a roughened channel, rough rock ramp kind of looks like. This is from a project we did here in Oregon a little while ago. You see that there's kind of the whole stream width is covered by rocks. You have kind of a low flow channel coming down through the middle. You have a variety of different sized rocks kind of all over the place. Some of the advantages are it mimics a natural stream. It allows for a passage of a very wide variety of species. Some of the disadvantages is it takes more space than some other passage approaches. You can see here that this is a pretty long one, and it's the whole width of the ravine and 150 plus feet on downstream to get there. And there's also this possible O&M that will need to take place after flood events, and this is part of it being mimicking a natural stream. Is natural streams have movement after flood events, and so this one likewise will probably have some movement after flood events, and so it'll be kind of an ongoing O&M for the district, for NID to keep an eye on that and make sure after floods come through, if things have moved significantly, if velocities need to be measured again, just working with CDFW to make sure that it's still meeting the criteria. So here's just an image from that concept design that we did. We'd take out the existing structure, which sits right under here. We would replace it with this roughened channel that would flow right on down to 150 feet here. And then we'd have some sort of a scour pool to help dissipate that energy, create, just a spot for fish to be able to recover, but also kind of define the bottom side of the roughened channel to limit head cutting if any head cutting is coming on upstream. On the leading edge of this, I guess we'll see this in the profile also, but we'll probably be putting in like a sheet pile here on the leading edge to really define that crest shape and that crest location to make sure, again, that whatever water flows over there, it's not changing what's happening there at the crest. So then there'd be a riprap that would go in, rocks that would go in that are sized to the required roughness that we need for the slope. And then there'd be these larger boulders that would be placed around to kind of create a skeleton for the system to hold everything together. But also, as I mentioned before, create these areas of refuge where fish can rest behind the boulders. This down here is just a quick, give you an idea of what a cross section of this might look like. We'll have some sort of a low flow channel. It probably will be triangular because that low flow is pretty low. That 13 CFS that's a low flow. But then as the water fills up in that channel, it'll just spread out onto the sides here and widen out. And again, we haven't gotten to this point of design, but most likely this channel is going to end up not being a straight line like this thing here. It's going to end up being, have some sinuosity to it to kind of flow down through and give a little more creativity and variety to this, so it doesn't look quite so engineered, I guess. Looking at a profile of this, again, would be coming in, water would be flowing downstream this direction. We'd hit this crest. We'll be, removing the old structure and we'll be putting in the new one right here. One of the changes in this concept design over past ones is that we're proposing that the new crest sit at the same elevation of the existing concrete sill that's there. In past reports that have been done, they've been talked about lowering it down 2 feet. But we believe that with 150 feet of run in our roughened channel, and right now we've got a slope of about 4.5%, that we meet the criteria, and we think that this is a very workable solution. By keeping that crest where it's at, it really helps with the concern over sediments that have collected behind the dam, the existing structure, that those will be able to remain. I believe it really helps with the concerns over bank stability upstream, that if we were to lower this crest by 2 feet, that creates potential issues on upstream with those banks that are already seeing some erosion happening. And so by keeping that there, it helps those two things. It also limits the amount of canal that might need to get regraded. And so, we're still losing the 3 feet of flashboards that were up here. So we're losing some water surface elevation, but so we might have to do some canal regrading, but by keeping that crest here, we won't have to do nearly as much. Here I've also just kind of shown where those low flow and high flows, what that might look like coming down through here. Alrighty, and then I think onto the fish screen. So this is the concept design we're looking at is for a farmer's horizontal screen. This is a screen where the water would come in from the head gate along this path. It would kind of get to this section, and in this section right here is where the screen would be, and it would be a horizontally oriented screen. And then fish would just flow and debris would flow over the top of it and would exit out here and go back to the ravine. At the same time that fish are flowing over, water is dropping out the bottom and going over a control weir and then into an attenuation bay over here. This image here kind of shows that as fish are coming down through in this top section, that would be this area that's screened right here. The water flows down through this screen and it has to come up over this control wall. And this control weir here really is what maintains the water surface elevation in here to make sure that fish don't get impinged on the bottom. So we would keep like a foot of water over the top of that screen to allow fish to continue moving on down. And then the water goes over the weir into this bay here, this attenuation bay, and then flows out into the canal. As the water comes along this section over the screen, maybe you can see that it gets narrower, that the wall kind of pushes the flow together, which really tries to keep the flow, the sweeping velocity high and moving up as it moves on down here. So that just keeps everything moving on down and allows the water to come out through the screen. So some of the benefits are it doesn't require power. It's a passive cleaning technology. I put in here NIMS compliant, but Beth had pointed out to me previously that while it meets the NIMS criteria, this is listed as an experimental technology in the current NIMS guidelines, but it's one that's been, we've used it in a number of places here in Oregon and Washington, Idaho, Nevada. It's been used in a number of different places, but it is something that's very site specific. And so with this type of technology, it's important that it's applied in the right site. And we really believe looking at this, that this site would work very well for this type of system. There are options for sediment control here in the attenuation bay. And so that's something that as we continue looking at this, unless we can very confidently deal with sediment at the head gate, we'll be putting in some sort of system that allows, they've got a system that allows for the removal of sediment without having to shut down. And so that's something we look at there. Some of the disadvantages is it is kind of a larger footprint horizontally than a lot of other systems, because a lot of other screening systems are set up more vertical. The problem with those, I guess the benefit of those is they use less space, but the problem is because they're vertical, you end up collecting a lot of sediment or dealing with sediment at the bottom of that. And so that's always a challenge. And it does require a fish bypass that, since it's in the canal, it does have to have a system of returning the fish and the debris back to the stream. And you see that here. Here we'd have a new head gate. We have a new pipe coming through into the existing Hemphill Canal. And then you'd hit the screen, and then here's the fish bypass. What I've shown here and what we're proposing is two separate screens, a fish screen 1 and a fish screen 2. Each of these screens can handle anywhere from 3 to 10 CFS. And so to meet those current demands of 3 to 9 CFS, we could do it with just one screen. But in the future, if the district wanted to expand or it wanted to put more water down the canal for whatever reason, there would be the option to easily just put in another screen, connect it in, and they would be able to just increase their flow that way. A profile of this system would look something like this. You would have, this would be the kind of the ravine out here. This is the water surface elevation at that low flow at that 13 CFS flowing down the ravine. So you get a little bit of water that would be able to come in a little bit over a foot. And this here would be the screen, the farmer's screen area in here. There's a bit of a head drop as you come out the back end of that. And then we'd be able to get into the canal. And it is likely we'll have to regrade the canal some, but like I mentioned, we're just not sure how much. That'll depend a little bit as we dig deeper into the hydraulics. And it's possible that this whole head gate fish screen setup needs to move down a little bit more in order to get enough water and to get the flows working right through the whole system. So that'll be one of the things that we'll be digging into here in the next few weeks, month or so, as we move toward 50%. So that's really kind of the walkthrough I wanted to do on that. And then, yeah, if there's just any questions, I'd be happy to take a swing at them. And I've also got Kevin here online, one of our engineers that has worked with these things more than I have to bring his experience as well. So I guess, I don't know, Tanya, do you want to be in charge of questions or?
Yeah, we can go ahead with questions on the design review at this point. The best way is probably to use the raise your hand function, and then I will ask you to unmute. And if you guys want a moment to digest everything, we can move on to permitting too. Okay, Jim.
Yeah, Jim Hoffler here. I had a question about the bypass. Where the bypass approaches the creek and actually goes into the creek, are there provisions there to make sure the fish aren't going to have a drop and bang their little heads on the rocks?
Yeah, so there are, there's criteria of what how much of a drop that needs to be to make sure it's not too much or not too little. And so, yeah, that will be definitely one of the concerns or one of the things we'll be looking at. And I think there's plenty of drop. I mean, there's plenty of drop from the back of the fish screen back into the ravine to give us kind of leadway of how that works. But yes, we are aware that we need to be careful of that and make sure we do that correctly.
And also in regard to the outlet there, will the flow through the bypass be shut off during salmon and steelhead migration season so they don't try to get up into the outlet?
I think normally we have a kind of a hydraulic disconnect between the two. And I guess I can't remember off the top of my head what that is. I don't know, Kevin, if you know that.
Well, so NIMS has criteria on bypasses being not submerged. So there's a little bit of a free fall Not so much of a free fall that the velocities exceed 25 feet per second. That's the criteria, but there is a vertical separation between the outfall and the high fish passage design flow, so that 5% exceedance flow, to make sure that it's that outlet pipe is never submerged.
Okay, thank you.
Beth. You may have to unmute yourself again, Beth.
Oh, can you hear me?
We can hear you now. Yes.
Okay. I was wondering if you guys could just talk a little bit about the previous recommendation. The last time around in the CEQA documentation had talked about having a vertical screen. And I was wondering if you could just talk a little bit about the genesis of your, deciding to go to a farmer screen here instead of, what had been made in the previous recommendation, or, sort of having a in canal but lowered cone screen or something like that. I was just wondering if you could talk a little bit about your thought process in making this recommendation.
You bet. Yeah, really. So a lot of it comes to that whole, we're losing water surface elevation. So the way the district had always operated is they would, put in stop logs, they'd raise the water surface elevation up 3 feet, and that would give them the head they needed to get into the canal and on downstream. And so we're losing that 3 feet. What they looked at before was losing another 2 feet of that water surface elevation. And so what that means is to do a vertical screen in order to get enough screen square footage to be able to meet criteria, you'd end up having to have the bottom of the screen lower than the crest of the overflow down the fishway. And so if you do that, you're just guaranteed to have a sediment issue. I mean, that would just fill up with sediment really quickly, I believe. And so keeping those sediments moving downstream would just be really difficult. And so for the vertical screen, that's definitely a problem. I think this cone screen would be a little bit better, but it still requires more depth to it than the horizontal screen. And so that's what we really liked about the horizontal screen, is it allows us to get the water out of the ravine through the head gate with a relatively low head, with just a foot and a half ahead. We can get that water in there, and then we can deal with it once it's in the canal. And since it's a horizontal screen, you aren't having to go down to get that screen square footage. And so that's really what it was about in my mind as I thought through that. Does that kind of make sense, Beth?
Yeah, I think it makes sense. I mean, I think our question is just about whether or not the not having been through the hydraulics to look, comparing the NOAA fish screening criteria, with the foot of depth at the end of the screen, just, making sure that we can really achieve that throughout the diversion season and in all water types, because it does get pretty low. I mean, that 13.3 that you were pointing to at 95% exceedance, I think that's right, but also during some seasons, I think when fish are even in there, maybe it's October during the outage, so there's maybe not juveniles out migrating, but it does get pretty low, down to 5 or so CFS. And so, I think we're just thinking through sort of those questions right now and trying to understand what's best.
Yeah, I think so. That makes total sense. And so I think, and I mentioned just a little bit, but like the elevation that we put that horizontal screen at, we haven't gotten to that yet. And so, if we need to drop that a little bit to be able to make sure we can keep that foot over the end of the screen, or to make sure the hydraulics work, we have a little bit of flexibility there. But yeah, that is something that we're gonna start digging into pretty fast and pretty hard.
Okay, Jeff, you can go ahead and unmute yourself.
Thank you. So my question is the location of the screen. Where approximately does that screen go, and how does it affect the canal that provides me with water? And how low I'm understanding that it's going to remain the same height as it currently is today. How deep are you going to have to go to get water into my canal?
Yeah, Jeff. So the that screen where we've got it right now is sitting pretty much where that existing gauge station is on the canal. And so if you've been down, to the diversion point, you know where that's at. Which is one of the things I guess I kind of skipped over is that, where we're proposing to put that screen is right where the gauging station is. And so we will be replacing that and, having some way that we can measure water either through the screen or just downstream of the screen. So that measurement of flow in the canal will obviously continue and will show up here in the next round of design. So how far we have to go. So my hope, Jeff, is that we are, in ideal condition, we wouldn't have to lower the canal at all and things would just work. I don't know that we're going to get there. So I think that we might be lowering the canal some. But I still believe that we can do that. That once you get to that first crossing in the golf club there, that by that point water would just be flowing normal like it's always flowed in the canal. So the bottom of the canal would be where it's at now. The water surface elevation flowing there through the golf club would be the same. And so I'm not sure where your takeout is or what that looks like specifically, but before we get to any of the turnouts or any of the deliveries, we would have everything back to normal.
Yeah, where we receive water from, I guess it's hard for a layman to look at that and go, where are we elevation wise, from the ravine to where the water flows into our lake. So I'm just curious, how, if we lower it, obviously that could be a potential problem for us.
Yep. Yes, I'm definitely aware of how that all works, and yeah, we'll keep an eye on that, and we'll definitely be working with NID, and I'm sure we can verify how that's going to affect you or not affect you as we move forward.
All right, thank you.
You bet.
Okay, Jim, you can go ahead and unmute yourself.
Okay, yeah, Jim Hoffler here, Friends of Auburn Ravine. Regarding the low flow periods, in our experience, there's almost always a low flow period from late September until whenever the rain starts in that fall period of time. Because by that time, the customers downstream from Hemphill, which are typically PCWA, Placer County Water Agency customers, they're getting to a point where they sometimes don't need any water during that period of time. So you'll get that low flow section there from maybe to, the last couple of weeks of September into the middle of October, if there's no rain coming down. And then sometimes there's a low flow period right after irrigation season starts where, orders have not been placed for water. So do you guys have access to the PCWA records as to how much water they deliver during the irrigation season? Because that water flows right over Hemphill.
I don't know that I've seen that, but I imagine I could have that.
Yeah, it might be good for you to get, because it would actually help your head calculations. You may have more water there just because of what PCWA does than other indicators would lead you to believe.
Yeah, that's something we can put on our list to reach out to PCWA and get for you, John.
Yeah.
Thank you, Jim. Yeah.
Thank you.
Yep.
All right. We have Jean. You can go ahead and unmute yourself.
Hi, thank you. Can you hear me?
Yes.
Yep.
Thanks. Jean Costello, NOAA Fisheries. And I was just curious, John, I believe you mentioned it acknowledged sediment loading and how to control that. In past reports, it's been acknowledged that Auburn Ravine has fine sediments, and there's still a concern, with that suspended load going down into the canal. How do you plan to address sediment so it doesn't clog the screen should that occur? Over.
Yep. So so really the experience that the farmer screen has had, definitely they haven't been in this system, and every system is different, and I understand that. They have had a lot of experience here in Oregon on some very some streams with really high sediment loads and have dealt really well with them. And so some of the sediment just goes right over the top of the screen. Some of the sediment drops down under the screen. They found that in some instances, the sediment kind of reaches a kind of a balance point where it kind of fills up in the bottom corners underneath the screen, but then hydraulically it gets to where it stays in suspension and just heads on down the canal. And then they've also put in these systems where you basically put in, it's basically a drain pipe that goes along the corners of that in those screens, where you can open up a valve and you can kind of flush out sediment and flush it back into Auburn Ravine. And so I don't know, Kevin, can you explain that a little bit better?
Yeah, sure. That sediment flushing system. I mean, it's basically that, you've got these tubular pipes that sit on the bottom of that attenuation bay, and they're perforated and they're connected with a valve. And as you see, if you do see fine sediment accumulating over time, you just open the valve and it will, in time, flush that accumulated wedge of sediment. That's really it really addresses suspended fines that happen to settle in that attenuation bay. The real challenge with screens is the sand size class, and we're not really anticipating a large sand load here. But over time, if sand does get caught in the wedge wire screen, for instance, it can just be brushed off. So I mean, it's fairly low tech maintenance required, and again, anticipated to be fairly infrequent. And then on the larger side, on the bed load side, that's not going to be an issue here. So really, it's just the fines and whatever fines are transported down canal now will continue to be minus some fraction that would be discharged to the river if we opt for that sediment sluicing approach.
Is that something, that information on, I don't know if you're talking about the screens in Eastern Oregon where these farmers' screens have been installed, but you guys have mentioned the NIMS criteria a few times here and in the reports. And so that it's still under the experimental technology in NIMS 2011 that you cited. So within that, it says that you would give background research on this technology. So will we be getting a report of sorts that can kind of show us areas that are similar to this kind of bed load that we have here on Auburn Ravine, and that what was done to accommodate those other already existing projects? You've mentioned doing some here, but John has mentioned each site is unique depending on, its location and watershed characteristics. So I guess I'm asking, are we going to be getting a subsequent report that's going to kind of cover that research of other sites and how they performed in relation to being similar to this site? Thank you. Over.
Yeah, I think we can do that. That we can put together. I know that the farmers screen folks have gone through this process a number of times, and so we'll touch base with them and see if they can get together some project examples of what they've done, where they've done this type of thing on a similar size, a similar type setup of what we're looking at here, a system that we're looking at here, and get that put out to you and I guess to everybody that is interested in that.
Thank you so much. I just think that would help expedite our review of the project. Thank you.
We definitely want to do that. I guess just one other comment I was going to have when we're talking about that sediment removal, and I can just imagine when we talk about opening extra valves in a fish screen, that gets a little scary. But since it is on the back side of that control wall, when you open up that valve to move the sediment, it doesn't affect anything about the water flowing over the top of the screen. And so just so that we know that, so that's clear.
Oh, thank you. No, that's a really good point, because it kind of made me think, trying to think of a vertical plate screen where
Right.
if you're changing behind, then your approach velocities are
Yep.
being altered and you could have hot spots. And so, yeah,
Yeah.
trying to understand a little bit more of how that works, at least for me, is going to be instrumental in, making good comments back to you guys.
Right. Right. Very good.
Yeah.
And I
that,
guess, yeah, go ahead.
Oh, I was just going to say, yeah, that control weir is a hydraulic control. So anything downstream of it, it would leave everything upstream unaffected, like you guys are talking about. I do know of one really interesting research paper, and I think there's a report associated with it that the Farmers Conservation Alliance did with Jilks and McMillan Jacobs that I hope to get out to you guys. We just need to check on it. That was a CFD model coupled to a physical model that looked at the hydraulics at different scales, all the way down to the wedge wire scale, with pretty interesting results. So I think you'll find that pretty cool.
Cool.
Yes, thank you.
Great. Do we have any, we'll have another opportunity to ask questions, but does anybody have any more questions right now? Jean, did you have one other question?
Yeah, I'm not sure where you're going on the agenda, but I was just wondering also on the grade control areas, John, what are you proposing for those? Like, what's the material? Are we talking like sheet pile with a cap? I'm hoping, if you're going to use metal, but what are your thoughts on that?
Yeah, so we're thinking a sheet pile, and yeah, it'd have some sort of a cap, or yeah, somehow it would be protected so that fish aren't hitting the sheet pile. But yeah, that's really what we're looking at, is the most logical step to take to control that water going over the crest.
Okay, thanks.
And I just add on to that too. One of the benefits of the sheet pile is that it will help, keep seepage water at bay and, maintain surface water. So, installing a cutoff that acts as a grade control also is sort of, killing two birds with one stone there.
Mm-hmm. Thanks.
Okay. So in terms of agenda, if nobody has any further questions at this point, we'll go ahead and we'll move to Dave, and he'll give us an overview of the permitting. We will have another opportunity for questions on both the design and the permitting after that. But if anybody has something that comes to mind, I could unmute you at this point. Okay, Dave, why don't you go ahead, please?
Okay, I'll keep this pretty brief, since I think a lot of people on the phone have seen this last week. But here's where we're at with the permitting status. So NID did retain my company eCorp with myself and Chris on the phone here to handle the CEQA, and the final EIR was completed in July of this year, so just a few months ago. So we are now into permitting. Our current timeline is to work through the end of this year and into early next year to try to get all the permits in place. And we're doing this on a parallel path and intertwined with the work that McMillan Jacobs is doing on the design side. And we're hoping to get this done early next year is the plan, so that we can get boots on the ground out there and start in-water work by summer of next year. As far as the permitting process goes, NID is seeking coverage under the Placer County Conservation Program, or the PCCP. There are two parts of that. The first part is for ESA coverage under the habitat conservation plan, and then also the California Natural Community Conservation Plan. The second part of the application is for Clean Water Act coverage under the County Aquatic Resources Program, or CARP. NID is not a permittee under the PCCP, so to get coverage, they're seeking coverage as a participating special entity, and that process is already underway to work with the county to get NID in place as a PSC. Last week, a lot of you on the phone were in attendance at this meeting, but we had our pre-application meeting last Wednesday, November 10th. Right now, I think our biggest constraint right now as far as getting the permits done is really getting the design of the fish screen and the fish passage itself to a level where we can get the permits completed and into the agencies for review. Go to the next slide for some reason. There it goes. Okay. So the PCCP itself streamlines the permitting process for multiple permits. The Clean Water Act Section 404 that will likely be done under a PGP 18 also provides coverage under the Clean Water Act for the Regional Water Quality Control Board, and provides take coverage for ESA listed fish under NIMS and U.S. Fish and Wildlife Services jurisdiction. As John mentioned, we have 2 covered species in the PCCP, and those are Central Valley steelhead and Central Valley fall wren Chinook salmon. Steelhead is a listed species under the Endangered Species Act, and the reach of Auburn Ravine, where the dam is critical habitat for steelhead. And then the 3rd species is a special concern species under California, and it's the Pacific lamprey. So in addition to the PCCP, there are a couple of other additional permits that are required. One is the notice of intent for the Regional Water Quality Control Board to get the Clean Water Act coverage. And then also a CDFW lake and streambed alteration agreement is separate from the PCCP. So these are the permits that we are currently working on. And again, hoping to get these all completed probably early next year so that NID can get the contracts in place to get the work going next year and be done hopefully in early 2023. Any questions on that?
Okay, thank you, Dave. So just a really quick recap at this point. I'm hearing concerns about the farmer's screen. John and Kevin are going to get some information available, and we'll provide that information via email, as well as potentially putting it on our website. I think we'll do that so that everybody has access to it, and hopefully they'll take care of some of the concerns regarding the farmer's screen usage on this particular project. I haven't heard any concerns yet about the rough and rock ramp design itself. If there's anything that we should know about, please let us know that now, because we are looking to proceed with a 50% design, and we don't, if we're going to change course, we have to do that at this point to be able to meet our timeline. And so we really appreciate the efforts that you guys are putting in now to review what we have in terms of the design concept, so that we could move forward with our 50% drawings basically in a month. I don't know if everybody got the agenda or not. We put that on our website, but we are looking at a 50% circulation to everyone mid-December, December 15th. So that's a pretty quick timeline here. So with that, we're looking to have, I think Jean brought this up at our PCCP meeting, whether or not we'll be looking for written comments. If everybody can submit to us written comments by this Wednesday, the 17th, by the end of the day, that would be great. And we could move forward with our 50% plans. So I see a few hands raised here. I'll go ahead and unmute Steve. Go ahead and unmute yourself.
Hi. Hey, thanks. Hey, I have a timetable related question. And Dave referred to some work being completed in early 23. And we've been proceeding under the assumption that the project would be complete in time for the 2022 salmon migration. So yes. Are we still in line with that, or what's the status?
that is the goal. With the timeline that we've created, all the in-water work would be completed in time for that fall salmon run. Any additional work that we have to do would be within our canal. That's why we have a schedule going to 2023.
Thanks.
You're welcome. Jean, you can unmute yourself.
Hi, yeah, I just wanted to say there's no way I'll be able to get comments by Wednesday.
Okay.
Kind of, this is meeting last week was the first time I even had a chance to look at the documentation, and I guess I just thought we'd get this presentation and then I'd have my 2 weeks to look at this. I apologize for that assumption on my part. I'll try and get you something by Monday, if not earlier, but that's just the best I can do. NIMS, our biologist here, might be able to get you some comments on the biological aspects, but
Okay.
it's a crazy week. And I also wanted to just say, we're just getting up to speed on this. It's the first time from the EIR that, all along in my mind, even when the documentation came in, I didn't open it and I thought, oh, we're flat plate screen, rough and ramp, we're good to go. I wasn't too concerned. And so now we have, that word concern, Tanya, you used it. It's not that we just need to get up to speed. We need to get where you all are and just make sure, as you guys have already pointed out, that this particular kind of screen is definitely the kind that you need to make sure it's the right site for it. That may be, we just need to hear from MJA and ECOR or whoever else is working on this, that everything that we know that needs to be for this kind of screen is they're like checking the box. So I was thinking maybe I'd send you, John, a spreadsheet that I made on our criteria and you could fill in the boxes if that's helpful or not. I'll send it, you can use it or not.
I can definitely do that, Jean, and I'll get on sending information to you, more information on the farmer screen here today as quickly as I can.
That would be awesome.
Get you as much background as quickly as we can.
And yeah, thank you, Tanya. The rough and ramp, it looks great. We're pretty excited about that. So I feel like, aside from just maybe taking a deeper look at it, it's not like, oh no, we don't want that. That's, I think, going to be a nice, elegant solution, as long as, it works at low flows and it's doing what you all need and what we need. I think it's a good choice. I just want to say that. Thank you.
Great. Thank you. Yeah. And I appreciate that, that the schedule is really compressed, and it is that we want to keep the momentum. We do want to keep the engagement. We do want to make sure that we get everybody's concerns or questions addressed throughout the process. But we are really wanting to start construction the beginning of as soon as possible in 2022, so that we don't have to push off this project to 2023, because we realize that in-water work window is short, like June through October. So we're trying to run steadfast towards that date. Let's see here. Beth, go ahead and unmute yourself.
Yeah, I just wanted to echo Jean's comments that I also will not have comments in by this Wednesday. I think that, as she said, we really are just having a chance to understand this now. And so we don't have totally free schedules, so we need a little bit of time. I will shoot for having you comments by close business Friday.
Okay, thank you.
And also just that I think that we should plan to have more conversations as we go through this, even if you have a schedule set up. You're going to get our comments back, and I know that you're going to a 50% design review or design set, but I think that how do I express this? I think that more conversations earlier, rather than pushing to get to a design set, is a more valuable use of our time at this point, because if we can do, there was a lot talked about modeling today and making sure that we're meeting those criteria. And so sort of upfront modeling and discussions to make sure that we're all on board with this, I think is going to help you in the long run so that we don't have to take steps backwards. And so I don't know what that means in terms of your timing, but another review meeting like this, as you push into that design set that helps us understand how you've addressed the questions that came in, I think would be a valuable use of everyone's time in sort of keeping things all on the right track.
Okay, all right, noted. Thank you, Beth. Okay, let's see. Scott, you can unmute yourself.
Thank you. Has the NID board already appropriated the funds that are needed to move forward on a timeline for the project to be completed by 2023?
The Hemphill project is shown in our capital improvement budget for the coming year. The board will be discussing that, I believe, at our December board meeting, if not a special meeting, but it'll be done this year.
So that means they haven't appropriated the money yet.
We need a board action, but we have supportive board members on this project. So I don't want to say that the funds are in place, but we do expect that the board will be approving it.
Thank you.
Jim?
Yeah. Question about the horizontal screen. In the image that was shown, the horizontal screen, the upper side of it was open to the air. In the final design, will there be some sort of a screen to keep predatory birds and other vicious beasts out of there and protect the little fish?
Yeah, right now, you're right. It's and that's kind of how we'd been thinking about it, is it would be open to the air. So I don't know, that's something that I guess we could look at or could be talked about of whether that's something that's needed or not. But yeah, at this point, it would be open to the air.
And predatory birds also include 10-year-old boys. So, and then also,
I can help that.
You got a plan for 10-year-old boys.
No,
anyhow,
raise them up as fast as you can.
I guess that's it. So another thing, I think you already addressed this. So on that, the sheet pile at the top of the slope of the Rough and Rock Channel, you mentioned some idea of maybe somehow rounding that off for the benefit of fish, and I would guess for the benefit of the lamprey as well, so they could make it over that.
Yeah, yep. Those things, that would be good to look at that as well. Yep.
Okay. Thank you.
Thanks.
Okay, Jeff, you want to unmute yourself?
Yeah, just a question. Who's going to be responsible for the construction phase? And is there a person that could meet me out on the site and walk me through what the construction looks like and how it'll affect the delivery of water to us?
Yeah, absolutely, Jeff. So NID will be managing the construction side of things. And as the design progresses, we can set up a meeting and we can talk about our expectation of the actual construction out there. And we can also schedule another meeting when we have a contractor on board to talk about it in further detail at that point.
Okay, thank you.
You're welcome. Okay. M. Cavaney, you can go ahead and unmute yourself. I'm sorry, I don't have your first name. You may have to hit your microphone if you're using either the app or the from your web browser. There's a microphone on the left-hand side bottom that you may have to hit to unmute yourself there.
And Tanya, that's probably Michael Cavaney with Club
Michael.
Corp, the golf course. Yeah.
You can also type your question in the chat box if you're having trouble unmuting, and I could read the question to everybody. Does anybody else have any questions at this point? So what I'm going to do is get together a meeting summary of what was talked about here today, kind of highlight some of the issues. And then I'll send that out to everybody. I appreciate everybody trying to get comments back to us as soon as possible. I'll talk to Doug about future meetings in between this 50% design review meeting, which we're looking hopefully to have December 22nd. And just kind of looking further into the future, we're looking at a 90% delivering folks in 90% January 26th, and having a meeting to look at the 90% February 3rd. All right, I'm not seeing any other questions at this point. Oh, wait. Beth, you want to unmute yourself?
Yeah, do you want those comments to come into you?
Yes, please. If you can email the comments to me, that would be great.
Okay.
Thank you. Jim?
Yeah, I don't have a question. I just have some good news for everybody regarding the salmon runs in Auburn Ravine. We've had our Salmon Survey volunteers out the last few weeks on Saturdays. And the biggest count we had was just this last Saturday, where we counted over 60 live fish downstream from Hemphill, and in the pool right below Hemphill, another 30 or 40. A little hard to count them when they're in the pool. So we got somewhere in the range of 100 fish stacked up in that section from like Liberty Lane area in Lincoln all the way up to the Hemphill Dam. And in addition to that, we collected DNA samples on 8 fish so far. So quite a good turnout for the salmon this year. That big water that we had a few weeks ago really brought them in.
Yeah, cool.
And we set a new Auburn Ravine record for fish size. We got a male carcass that was 110 centimeters fork length. So that's 43¼ inches long. That's a big fish.
Wow.
Yeah. End of report.
Thank you.
Yeah, let's get that passageway in there so they can get on upstream, right?
Yep.
It's the plan.
Yeah. All right. Well, thank you everybody for coming. If something does come to mind after this meeting, feel free to email me. You can email me your questions. You can always give me a call. We do want this to be a successful project. And yeah, thank you very much for your time. It's much appreciated. And we will be talking in the very near future.
Thank you. Bye-bye.
Thank you all. Bye-bye.
Thank you.